Hey, hi everyone. My name is Pavam. And if you have seen my previous videos, you would by now know that I'm trying to make some videos of questions which I think could be asked during interviews, especially on the front end side. Uh, and I did JavaScript in the last one. I'm going to stick to JavaScript for this one, and I'll go back to React in the next one. So for this one, I'll cover, a, I think, a very commonly asked question, which is debounce and throttle. And I think it's important to know the basics of these two and know a little some advanced functionalities, which could be your second question asked if you once you implement the debounce, which is to add capabilities like leading and trailing options as part of debounce. And also we'll discuss throttle in this one. It's also important to know what's the difference between debounce and throttle and when do you use what, especially because of the way these work. You need to know what's the function which is going to get executed at the end. Uh, like, for example, if you're scrolling your window uh, and if you're trying to do some computations, which you're going to use for viewability, you need to know whether to use throttle or debounce. The main reason being that you need to know what's going to be the function that is going to get executed at last. If it's an earlier function, the values that the function could be holding inside as a closure could be older one. So your viewport calculations could go wrong. That's why it's always important to use the last one. Uh, and same thing with input keys. When you're trying to debounce or throttle your keys in implementations like autocomplete, you need to know that what should be the last character that the user is going to use. And if we are honoring that as part of the debounce or throttle. So it's good to know the differences and when to use where. But let's start with implementing debounce. So debounce is an higher order function, which means that it's always going to return you a function. So the first thing you do is just return a function. Now, what's the whole logic of debounce? You're just going to, if you keep calling this function again within this wait, you're going to discard the previous function executions and then create a new timeout every time, which is going to be executing your function as soon as your wait is complete. That's the whole logic of debounce. So what do you do? As I said, there's set timeout inside it. So now let's do a set timeout over here. And we're going to do a set timeout for the delay that we have got, which is the wait. And in this case, as I said, this is a higher order function, so you're going to get arguments. And as I had said previously, if you were doing this with ES5, you would need to use arguments and array dot proto type dot slice dot call of arguments to cast it to an array. Because we're going to use apply for invocation, you can also use array from, which converts it. And you can use spread operator, which I've done over here on the top. So you're going to do a set timeout, and now within this, you're going to take your function, and you're just going to call this by passing the args to it. Just remember that this has to be the scope of this function on the top. That's why I'm using an arrow function over here. Arrow functions don't have a scope of their own. They don't have a this inside them. They're always going to take the this of its parent. That's why the context that this function is going to get is going to be of this wrapper function, which is what the user would land up invoking, so that the context is preserved. Now, as I said, the important thing is that you keep clearing this every time. So what do we do for that? So we use closure, and we store the timeout instance and initially assign it as null. And we're going to assign this to the set timeout. And we are just going to do a clear timeout. And this is your basic debounce. You're canceling all your previous functions by doing a clear timeout. Like all your previous timeouts are going to get canceled, and every time a new timeout is going to get applied, which is going to delay the function execution till the timeout has finished, which in this case is going to be the wait. Now, if you have done implementing this, the next things that you will get asked most likely is to implement the leading and trailing. So let's go over how do we implement leading and trailing. So what does leading mean? Leading implies over here that you're going to immediately invoke the function without having to wait for the timeout to finish. So if option is leading, you're just going to go and call this function immediately. So that's the whole point about leading over here. And this is not something that you would see very often, but there could be some use cases for your debounce where you want the function to be immediately invoked. In certain cases, that's when you would pass this leading parameter as true, where default in this case is false. Let's also keep a track if the function was invoked. So invoked is false. Now, in this case, invoked is true. One more thing you want to ensure is that when you're calling options.leading, you should only call it if there is no timeout instance. If there is a timeout instance, you're not going to call option, even though option leading is true, you're not going to call the function over here. Now, what do you do for the option.trailing? As you can see, option.trailing is actually the default behavior. But you could have that set as false. So we need to handle it. So if option.trailing is set as true and the function has not been invoked, then you're going to go and call the function.apply. And I think that's most of it. Yeah, one thing I forgot is you should go and make the timeout instance as null. So I think this is most of the debounce function. Let's try running this and see if it goes through all the test cases. Awesome. So it went through all the test cases. Now I'm going to go over this again. So you have, you're using timeout instance, you're returning a function, you're using the spread operator to get all the arguments. You are handling leading by invoking the function immediately. You're also handling the trailing, which is default, and invoking the function. And every time the timeout has finished, you're going to clear the timeout instance so that it's not -1, it's actually null in this case. Now let's go ahead and implement throttle. So what is the difference between throttle and debounce? So this one comes with a little tricky implementation, and I'll go over all of it. So again, this is a higher order function. So you return function, and you're going to take the arguments very similar to debounce. You're going to go and call function with the args, which is what we did in debounce, but we did that inside the timeout. But in this case, we are going to do that immediately. And we are going to hold a variable stating that should throttle, which is by default false. This is again using closure. But now since we have called the function now, we are going to start throttling it. So we are going to set the Boolean as true. Now what you're going to do is, if should throttle is true, you're not going to call this function. So next time when you're going to get called again, you're just not going to execute this function till the should throttle becomes false again. And when will the should throttle become false? So as soon as you finish the execution, you are going to now use set timeout over here, similar to what we did in debounce. And you're going to use the delay, and you're going to set the should throttle as false. So you call the function, you set a Boolean to true, and then you started a timeout with the wait. And then you're going to wait till this timeout finishes. and then you're going to set the should throttle as false. Now, one thing is I can just return over here, not do anything if should throttle is the on, uh, so that I don't create the set timeout again. So if there is a should throttle, just return and not do anything. Next time that the function is called, uh, if the should throttle is false, which could either be at the beginning or when the set timeout was executed, set the should throttle as false. There are a few things over here that you need to think of, uh, which is going to be a little advanced implementation of throttle, but it handles all the cases. And I'll go over that also. So this kind of works, gives you a very basic throttle, but there are things that might not be working as you would expect, especially what's going to happen once the throttle is finished. Would you be executing the should throttle, the throttle function again or not? So for that, what I'm going to do is I'm going to create a timeout handler function. And I'm going to call this timeout handler as the function instead of the arrow. And I'm going to handle the should throttle equals to false over here. Right. Now what you're going to do next is when should throttle was set as true, you want to still execute the function at the end once. Otherwise, what's going to happen is you're going to miss out on the last execution. And like I said, when you're trying to do a scroll and you're trying to do a computation, you might land up computing with the older value and not the latest value. So once the should throttle, once the throttle is completed, you should check if it was called once more. You reset the throttle and start the throttle again, and you execute the function with the last arguments. So how do you do that? You keep a track of what was the last argument. So let's say last args equals to null, which is a default value. And if should throttle was on, you're going to say the last args is equals to arg. So you're going to keep a track of the last argument that was supplied when the throttle was in progress, because of which the function was not executed. And now within the timeout handler, you're going to check if last arguments was present and only do the should throttle as false for the else condition. You're going to execute the function now with the last arguments instead of the args, and you're going to reset the last args back to null. So what now happens is, as soon as the timeout is finished, you're going to take the last value of the function that was called and re-execute it so that you can do a computation with the latest value as soon as the throttle finishes, so that you have that last calculation done. And in this case, because we had the last argument and we invoke the function with a previous value, it's best to again redo this. So we are going to start the timeout handler again over here, which is no. So we are going to set the timeout again over here in this case, and we are going to wait again. So we are restarting the timeout handler with the set timeout and repeating this all over again and checking to see if the should throttle should be initiated as false. The reason being is that you want to release the should throttle the next time a throttle is called, which handles all your cases. So I think that's most of the throttle function. A little different than how we do a debounce. And let's check if we missed out on anything. It's always important that you review your code and you go through it twice or thrice, so that your interviewer knows that you're not just testing by executing the code, you're actually also reading the code, which is important to show during your interview. So let's try doing a submit. I think I've covered most of it. Uh, Hopefully this works. Awesome. So this was the throttle implementation. I'll go over it again. You're going to call the function set should throttle boolean as true, create a timeout, store the last argument if the should throttle was on. In the timeout handler, you're going to check if there were last arguments, then call the function with the last arguments, reset the last arguments, and reset your throttle again with the same timeout as before. Note you have not set the should throttle as false now. So the should throttle as false will get set again as part of this. And if there's no last arguments, just go and reset the should throttle as false. Cool. Yeah. So that was all of it. Thank you, folks. So this is basic debounce and throttle implementation. A pretty common interview question from what I know. I would personally ask this to someone whom I'm interviewing to see if they're aware of these concepts. And even during design interview questions like autocomplete, where you would be mentioning debouncing for your input keystrokes, you might land up also implementing a debounce if the interviewer chooses to as part of a design interview question. Cool, guys. Thank you very much. The next recording, I'll try covering a React question.